Okay, everybody say hello. You're alive. Okay. I need a photo release from all of you now. Hi, my name is Drew Desker. I'm the director here at Kopernik. It's great to have you join us here this evening, both here in person as well as on the live stream. And so we look forward to seeing, for those that are on the live stream, we look forward to having you come up at some point when you're able to and in the area. I know we do have people that do view this from literally around the world. We had back last March 13th was the last time we had almost the last time that we had a live program up here until this past June. And when it was clear that we were going to be sort of in this mode of not being able to gather together in one place, we ended up saying, well, let's pivot and let's still offer our programs, but we can do it using technology. So we started to live stream. And much like everything else, it was a learning curve. But we've really enjoyed doing it. We've had some great great programs, some great events that we've been able to live stream. Back in July and August of last year was Comet Neowise, and Jeremy Cardy, who we call our live stream astronomer, came up and put a camera on one of our scopes, and we were able to do a live stream of Comet Neowise and talk about that. We've done live streams of various NASA launches, of the Perseverance launch, of the launch of the SpaceX Crew Dragon that had local astronaut Doug Hurley, who just recently retired from NASA. We covered his launch. We also covered the return to Earth. We covered the landing of Perseverance. But we've also, again, had some just great programs. There was actually a Union Endicott grad that now works out in California for a subcontractor to Jet Propulsion Laboratory, and he works on the mast cam for Perseverance. And what's also nice about the YouTubes is you can actually go to our YouTube channel and view them. So if you miss that or you want to see it again, you could just go right to our YouTube channel. But anyway, we are back open again, and let's hope we can continue to do that. If we could be smart about wearing our mask and getting vaccinated. But anyway, just a little bit of background. Let me just see here. I'm going to turn the camera around so we get some answers. Let's see here. Here we go. All right. Who's here for the first time? All right. A few people. All right. Who here are members? A few others. Okay. Well, one of the things I do mention, especially the first timers, is that the people who are members actually have a special knowledge, if you will, in that a Kopernik membership actually has some significant value. We are a nonprofit. We are not associated with any university, or we don't get any state or local money on an ongoing basis, other than some grants from time to time. So events like this, our summer camps, we do get some grants for some school outreach, is what keeps us open. But for you, a Kopernik membership actually ends up being a pretty decent deal. It's only $60 a year for a family, and we belong to what's called the ASTC, Association of Science and Technology Centers. And it's a consortium of over 350 other science centers that you can go to. So with a Kopernik membership card, you could go to the Franklin Institute down in Philly, or the Intrepid down in New York City, or Boston Museum of Science if you're in Boston, and you get in for free. So and your membership definitely helps us out. We also right now we're very fortunate to be able to hold our summer camps. And last year we had to do everything virtually. But this year we have over 200 students that have been able to come up, and we'll be continuing through the end of August 20th. And we've had some great times, a lot of good energy. Also, this is the first summer that the kids have been able to use the Kopernik Science Park, the STEM-themed playground that we have out there. I'm trained as an electrical engineer. My daughter calls me the fake astronomer. But I've got a laser pointer, so I can answer, I'd say 95% of the questions people answer. But we've got some great resources here. We have an astronomy club, the Kopernik Astronomical Society, that is resident here, and you'll be able to interact with some of them this evening. after the program when we go out and do some observing. But the thing I love about this place is it's an opportunity to learn. We all really should strive to be lifelong learners, and not that we're not trying to turn everybody into an astronomer or an engineer or a scientist, but even just being an informed citizen. And so that's why we do this. And it's great again to have people here. This is meant to be sort of a collaborative thing. So as you have questions, I know Keith, you can maybe Keith enjoys his presentations. You'll see. So as questions present themselves, you can either ask them there, or we could put them at the end of the program. But anyway, let's go right to the program. And today's program is about artificial intelligence, machine learning, and self-driving cars. We're seeing more and more of that that's available. And so Keith is going to take us from sort of the history through that. Keith also is a member of our Kopernik Astronomical Society on sort of future technology. So we're going to turn this over to Keith. I will get your presentation up and running as soon as I find it on my, here we go, presentation. We're going to find the PowerPoint. We're going to find that, and done. All right, so give me a moment. We're going to move on to that. And, oh yeah, there are 2 ISS passes. We may take a break and run out and see that go by. We can't tell it to stop, but then, and this won't be the first time we've stopped the presentation to go out and see the ISS pass. I'm going to tell you in a minute here as soon as I, oh, hold on. Where did we go? All right. So that should do it. Keith, if you want to turn on your microphone, is it on? The ONOFS all the way is 2 clicks. Yep. All right, let's go ahead and start talking.
Testing 1, 2. Oh, ooh, feedback. Oh, wow. Maybe it's too loud. Maybe I talk too loud. Whatever matters. What was that? I shouldn't. Oh, look, maybe that's in the way. Whatever. All right, I'll try it. Okay. As Drew said, I'm Keith Werkman, former IBMer, came up here in 1990, worked out in Owego with Lockheed Martin, who's made some hardware which bits and pieces actually are in this facility, believe it or not, like space shuttle computers and stuff like that you see out there. Then, of course, being a good IBM employee, they sold us. So then I worked for Loral, then they sold us again. I worked for Lockheed Martin, and they sold us again. I now work for Leidos, which is a company which is a spin-off IT company from Lockheed Martin. So anyhow, my background is in AI and computer science. And so during COVID, I really got into looking at self-driving cars, electric cars, actually EVs. And I thought we had a talk just last week, I think, by Jeremy Carty, who has a electric vehicle, EV, and his actually does simple level 2 kind of lane following, I guess. And I thought, I got to give a talk, and this is good stuff. So that's why I'm here today. And I preface this with saying this: I'm a Tesla stockholder, so it's biased. But as I did the research, I found out there are competition out there, which is actually, who knows, we'll see. So the clicker works. Okay, talk outline. We're going to talk about basically what. What if I just stand in front of this? What matters? Autonomous cars. The Society of Automotive Engineers, their classification. There's 1 through 5, or 0 through 5 actually. Why should we even do this? A historical perspective. The type of companies. I keep bumping something, don't I? Should I just take this off? Yeah. And then I'll move on to. Yes. So the top 5 companies, autonomous driving architecture, real quick. Some AI machine learning backends which make this all happen. What am I doing wrong? I must be bumping something. Slide stops. Then of course you may have heard of LiDAR. That's one of the 2 major solutions people are using to do the self-driving solution. Of course using vision. Then we'll talk about I think the top leaders, Tesla, Mobileye, and Comma AI. They'll do a little quick, if we have any time, race to the autonomous taxis, which supposedly is going to be a $1 trillion industry. And then some example videos. Those who really want to watch stuff, I've got Waymo, which is the Google guys, and they've been driving autonomously for a while in a geofenced area. But I've got, those are to kind of show when cars that are supposedly the best in the world just don't work. They get stuck on traffic cones, and then they try to come help you, and the car kind of runs away from the guys helping you, and it's kind of fun to watch a video at the end there. If you guys want to see that later. So levels of self-driving, 0. That's where I am. Yeah, I got 2013. I'm the self-driver. Basically, the human drives, human monitors. In case there's a problem, the human falls back to himself. And of course, there is you are yourself. Some of the cars out there now, I guess, unfortunately, like I said, in 2013, but if you have the 15, 16 earlier or on, have level 1 self-driving, if you will, which basically is the system assists the driver. And the video goes away. Okay, the system assists the driver, but the driver is still monitoring. And some of the newer ones, like I said, like the Teslas, unless I do use a hand mic, I don't know, maybe, or I just why is it doing this?
Here we go.
Imagine if you were driving. If you're driving at the end of the problem. These are the episodes we were talking about. So basically, Tesla and other cars are really at level 2 right now. Am I actually heard? Yes. Okay. Go ahead. And so the system actually will kind of drive the car through some of the lane, rain falling, rain or something like that. Human driver still monitors in case of problem, human takes over, and it does various driving modes. As it the rate following, with that cruise control, if you will, or staying in lane, or switch lanes. The good stuff comes from level 3, 4, and 5. 5 is where you basically fall asleep and park drives around. Unfortunately, Tesla's been seen on the roads, people in level 5 thought mode, and basically putting up the highways and that's not a good thing. So, I'm talking to Jeremy, president last week, his car. He said, yeah, it's great. It just takes over and drives. I mean, it's really like ass and that. Experience this kind of driving as well. So bottom line is, level 2, that's where things are going to stay for a while. There's a big industry, I think it's really good for level 5, moving products around, people around, having slow, self-driving vehicles, which you can get in the back, if you will, and driving around your, residence facility if you're an older person. These full product mobility people.
We've been hearing about self-driving cars a lot in recent years, mostly due to companies like Waymo, GM Cruise, Mobileye, Argo AI, and of course Tesla. There have been many more companies jumping in on the wagon in recent years, all racing to be the first to achieve full self-driving and getting the biggest slice of the pie. After all, the autonomous ride-hailing platforms are estimated to be worth $2 trillion by 2030. This alone tells how disruptive autonomous cars will be once they're fully utilized on the road. In this video, we will look at the top 5 companies with self-driving technology. But before we hit this show on the road,
Tesla, 1, 2, 3. Ah, there we go. So yes, big bucks in this industry. Amazon, like I said, 1.2 just for Zoox alone. Intel bought one of the major players who actually I think might even upset Tesla at some point. Mobileye from Israel for, as you see, $15 billion there. Ironically, the chips that Mobileye uses are still not produced by Intel, but maybe down the road they will be. Big bucks in this industry. Andrei Karpathy is the Tesla scientist or director of AI at Tesla who is leading the effort. And I've taken snaps from various online AI conferences they had because of COVID and stuff. He talks about the meat computer, which is what we're using today, our brain, and basically we're moving this 1-ton object at 80 miles an hour. We have a 250 millisecond reaction time, situational awareness, looking around, and when we check our Instagram, we die. So basically 3,700 people, I guess, a day in the world die from auto accidents. So the most dangerous thing you did today was actually drive here, probably, if you have a self-help driving car. He does say if we have the silicon computer, there'll be a tighter loop of control for this big object, much faster reaction time, 100 milliseconds, true 360-degree awareness, looking all around the car. We can't quite do that with our heads. It kind of hurts when we do that. And it'll be fully attentive. And I wish I had a self-driving car tonight because I could have been looking at my presentation all the way up and redoing stuff. It'd be fantastic. So I think a lot of people would actually enjoy that. You know, a lot of people who are, give me my car, I'm going to drive it. But I think the younger folks coming up might enjoy extra time in the car. This is just a slide from my old pitch, which talked about 30,000 people a year die, and 94% of those accidents are due to driver error. And most of the self-driving car accidents are not their fault. Some people running into these cars, ironically. So a lot of online systems. This is from Volvo. It shows bounding boxes around pedestrians and warning them. So there's a lot of additional safety features, not only to keep you in lane, but also for pedestrian avoidance, so you don't hit people, things like that. You may have seen recently some of the accidents with Uber and stuff. It didn't quite work because the computer didn't figure it out quick enough, and boom, a person with a bike between them and a car didn't make it, and they passed away. If they were probably on the other side, the car was seen inside a person and stopped, but because the bike was between them and the car, the particular Uber system it was going back and forth. Didn't know what it was. They thought bicycle, and it was too late. So there are issues out there, real issues. And there's also other situations which a lot of these cars are being driven in nice sunny places like Arizona, Phoenix, San Francisco, things like that. Not too much snow. Certainly not too many horse and buggies. This is actually just from the local paper today, right? Yesterday, talking about solutions for horse and buggies of motor vehicle accidents. And I can just imagine, hey, Tesla, come out here. Do some training on these guys with horse and buggies. That's probably not in your training set yet, or many people's sets. Of course, in the future, when this all gets working, like in about 10 years, or maybe less, from the movie iRobot, I guess, is Will Smith, I guess. Hey, what are you doing? I'm driving by hand. Don't do that. Too dangerous, right? History, yes. I work for a company called Leidos, who our CTO actually was a DARPA head when they had the Grand Challenge back in 2004 and 5. In 2004, none of the cars finished. So I said, let's do it next year. So 2005, they came back. And Stanley won. That's Stanford University. And others came in different times afterwards. Not too bad. But this is out in the desert, and they kind of just did their thing and tried to follow the trail. Sebastian Thune, he was the guy, and still is the guy. He's in charge of Udacity right now. It's an online training thing. But long history, worked at Google, worked at CMU, then left, went to Stanford, and won the event against his Stanford counterparts. But basically, he had a small team of just like 5 grad students, and they pulled it off with various sensors, which we use even today. There's Stanley. It's such an iconic thing at the National Air and Space Museum. Who actually? That's who's National Space? That's who's in Smithsonian, right? Smithsonian. They've got to pick points in time where they figure things would be important, and they chose a self-driving car, Stanley, right here, the first one to ever win a complete challenge. They actually moved into their museum for future. And you can see there's actually various sensors on top. These are called LiDAR sensors and stuff like that. We'll talk about that. Then in 2007 came the Urban Challenge. They entered again. But this year they did lose to his original the Simu guys, and many more teams entered actually for the urban challenge to see if they can drive around the actual streets. And in this case, Carnegie Mellon won, the Tartan team with a Chevy Tahoe. Ironically, I actually went to Lehigh University, but not at that time, unfortunately. The Ben Franklin team was University of Pennsylvania and Lehigh, and we actually finished, or the Ben Franklin team finished of the 20-plus teams, but didn't rate because it was after the cutoff time, 6 hours. Let's see what we got here. Is this gonna? This may be a video that works or not. It has a.
In the 1990s, tests continued with the same technology across the US with Carnegie Mellon University's NavLab project driving cross-country 98% autonomously. Fast forward to 2009, we see Google jump into the autonomy game with their Google XLab self-driving project, which in 2016 was spun off as a separate entity known as Waymo. And since then, many startups have emerged to make self-driving cars a reality. But there is a major difference in the way companies are approaching to solve this problem compared to Tesla. Most companies are using LiDAR and a number of sensors to allow the car to navigate on its own in the world. A LiDAR is a surveying method that measures the distance to a target by illuminating the target with laser light and measuring the reflected light with a sensor. Differences in laser return times and wavelengths can then be used to make digital 3D representations of the target. In this case, that is the world around the car. Tesla, on the other hand, does not use LiDAR. Instead, they use cameras and a forward-facing radar to handle most of the autonomous driving. Tesla's approach to solving computer vision is much harder and will take longer to achieve, but it does have its benefits compared to a LiDAR-based system.
Right. Bottom line is LiDAR and vision. Those are two competitors. Oh, LiDAR and vision are two competitors. Sorry, mic'd up, but I'm not mic'd up. And we'll talk about that in a second, too. I think I've had a... So this goes into the top 5.
Currently, the top 5 companies racing to get autonomous cars on the road for widespread public use are Waymo, GM Cruise, Argo AI, Mobileye, and Tesla. There are a number of other startups such as Zoox, Neuro, Aptiv, AutoX, Baidu, Comma AI, and many more that are at least as far down the road as several of the top 5 companies named above. By the way, Comma AI is open source and the founder was almost hired to work with Tesla at one point, but this is a story for another video. Waymo has been operating independently since 2016 and operates currently only in Phoenix. They have approximately 600 vehicles in their fleet currently, and they've mapped an area of about 100 square miles using LiDAR, which is geofenced so the vehicles can't operate outside this zone. Waymo currently operates at level 4 and has a driver behind the wheel to take over in case of an emergency. They do, however, have 5 to 10% of the vehicles operating without a driver for a select few who signed an NDA. And as we've just learned, Waymo will operate at level 5 for the next several weeks. Almost every Waymo ride in the Phoenix area will be without a backup driver. However, these vehicles are limited to a 50 square mile geofenced area. Later this year, Waymo will reintroduce human backup drivers behind the wheel in some of the vehicles so the company can work on expanding its service area to other cities. Waymo has driven over 35 million miles in the real world and more than 16 billion miles in simulation. That's an impressive amount of data they've collected which can help them improve the software down the road.
So the bottom line is you saw Waymo, 35 million miles. That's a lot of real-world driving. They're number 2 in the world. How many miles do you think Tesla has? 3 to 4 billion miles, and generating more daily by their fleet. So what it comes down to is training is great, but these weird edge cases require real-world data. And this is where I think Tesla's going to have the major lead over these things. You saw the LiDAR, right? It's shooting lasers out and reflecting back and seeing exactly how far you are, making these point models. But unfortunately, you have to be in a geofence or a perfectly fenced-off area, which is mapped with high-definition maps, so exactly where things are. What's the problem? Uh-oh, a traffic cone. That wasn't there before. Oh, what do I do? That's the real problem with the LiDAR systems. And by the way, that's the 2 approaches, the LiDAR-based ones, models, and pure vision. Pure vision is Tesla and Comma AI, and everybody else is on the LiDAR solution. If the vision systems work, the multi-tens of billions of dollars on the LiDAR solutions, oops, could be interesting. Could be very interesting. Who is actually going to win this, and if it'll be, the right thing. How do I get this back here? Here's GM Cruise real quick.
General Motors Cruise division has about 200 vehicles undergoing testing so far. They've driven more than 1.2 million miles in the real world. GM Cruise also runs a 3D simulator that gets 200,000 miles daily. GM's Super Cruise is used in some of their vehicles today that technically operate at level 2, with adaptive cruise control, steering assist, and lane assist. Just like Waymo, GM Cruise also uses LiDAR and radar along with a number of other sensors and cameras to help the system navigate through the real-world environment. GM has a big team working on an advanced version of its hands-free driving assistance system, or ADAS in short, that GM calls Ultra Cruise, which will expand its capability beyond highways and apply it to city streets. GM's Super Cruise uses a combination of LiDAR map data, high-precision GPS, cameras, and radar sensors, as well as a driver attention system which monitors the person behind the wheel to ensure they're paying attention. Unlike Tesla's autopilot, users of Super Cruise do not need to have their hands on the wheel. However, their eyes must remain directly straight ahead.
And just to talk about safety issues, yes, Tesla, we got pass?
Okay, for those that are watching on the live stream, we are going to take a pause here because the ISS is about to fly over. So we'll walk outside, and then when the pass is over, we'll come back in. So just meet me all out here in the lobby, and those on the live stream, just time for a bio break. We'll be back.
Do you like it? If we go outside, is it fun? We live on a dirt road. Yeah, a white car on a dirt road. Okay. As far as lighthouse, I had to do that stuff. Yeah, right. That's what we fall down the road like that. Now, the rural area doesn't have a field. Not for me. You're doing it. I got to get the next, 3 or 4 versions. You actually have FSD. So, are you in a beta program or is that? Okay, so the guy in the beta program actually. And it's like, yeah, it's like, how we got very impressive. Ages and trees are the board like that. But see, the areas of running, or instead of having a small piece of they're trying to say, well, real solution might be just lots of data and let it try to figure out by itself. It's not figuring out by itself. So far, it makes the same mistake. Yeah. So, well, I mean, your model may not be updated, and your model's different from, I don't know, maybe from the actual. It should have the latest hardware. Well, they're shadow monitoring them. But they might be putting the actual models on you and watching things happen. And the model said, if you were here, you could there. We're back then. Why do that? And watch the video and know how people try to label it for right learning. I'll talk about these things in a second. What have you heard about Apple? I was playing the game. If Apple gets into the game, they just buy Tesla. Apple is looking at, there's some rumor. Oh yeah, that Apple is going to get into. I have their stock too. Yeah, I have Apple stock. And just imagine someone gets to decide, okay, this is the job. Apple gets in and says, well, they're not going to build a car. They're going to buy a part of Hyundai. I think that's the rumors latest. I mean, they have so much money. They did a whole bunch of value price buy. Ford. But they're doing their own self-driving stuff too. Unless they sell solutions. But here's their Apple planning to do self-driving a lot. But then again, this whole talk about the data. You got the data, you're a winner. And as soon as they're generating, and you're generating, thank you very much. You're generating data for them. They can go back, they can ask questions like, there's a weird thing, it's a weird funny road here, a lot of dirt and stuff, and then there's a gate there, and let's ask the fleet, who has that thing? Maybe you drive down the road, maybe you're one people, maybe we'll sample your stuff down. We'll put a system, so we crush the game. And all of a sudden, that's a common thing now. I have to have a big computer. Yes, well, they have something they're building with. They have the fastest supercomputer in the world right now. And Dojo, their next thing will be
hopefully the fastest. I'm not going to be using the heaviest chips and video. I 5 hours a day to find all stuff.
Now,
But unless you want to see the capacity of other things.
accuracy of the GPS, how accurate is it?
Well, now, I think in the case of everyone else, they've got GPS to its high definition maps. I guess I don't know. I mean, they basically that's a GPS. I know I'm here in Pennsylvania or New York, and I know there's something here. But the LiDAR, it knows to the fraction millimeter where you are. Get the mapping against the side. And that's a problem. Also, for computing power, energy, and it's big and hot and heavy. It's a hard big space. But Tesla's nice and small because the big supercomputer go crush it all down. They say let's get a reduced version of run your hard mode. That's pretty cool. And run some kilowatts power. And it kind of analyze it. So it's basically you get all this stuff. Switch down. Say here. And people have the lazy this stuff. And it's just like putting the hardware. And it's version 3. Version 4 is about having 2 chips on this motherboard. They're going to have some crazy design where you have a whole piece of silicon and the whole system computer, and everything's going to be one chunk of silicon. And that's how they're going to kind of keep the power down. Compared to the competition, which is NVIDIA, which has a great solution, but NVIDIA's not selling chips to your self-driving car. NVIDIA says, I'm selling chips for AI researchers and guys in automation plants and all that stuff. I'm not going to spend $1 million or $100 million to build a chip just for you. I'm saying sell 100 million chips. If GM and Ford have to buy them, so they have a solution, but it's bigger, it can be faster, but it's not really that much faster, and it's bigger. It's just more expensive, heavier, and more power. So it's interesting for the players that make basics, specialized hardware. I'm sorry, time now. You guys, let's see, or you say you're all this stuff. So you must get in here then, or you must get in here.
Yeah.
See.
I spent some time in a video.
Oh, okay.
And, but,
oh, yeah. Back up there, that's 90. And Rocket 15. Of course, the IRS, of course, industry's like, well, research, go for contracts, so I'll exclude them. Things should change. In fact, like, it's spun off a lot. They said, well, your IT guy, you're going to make an 8% profit. You need hardware. We're going to make 10, 12% profit. What the hell kind of stuff like so. A lot of it's sold off. We have more than 20,000 people. And we merged with a company called SAFC, also IT stuff, now called Ligos.
where is your company?
We're virtual everywhere, but we're basically C. And my contacts have been on running on this recent HR Access, which is HR stuff for PSA. And I just finished up with 12 years, so I thought that was kind of I said, no, you don't love me. So I found another job in Ligos with DA Defense Civilian Personal Data System. So HR again. So civilian contractors who run the defense department. So same sort of stuff, same kind of data warehouse kind of stuff. Not really cool. I still want to do it, but the whole implementation is doing it happening. We've gone for a couple of years. But Apple comes through their relationship too, and they're trying to play this game. Who knows? They want to turn around and buy. I think Apple, Tesla went to Apple years ago and said, you want to buy us? If they did it now, they
It's just on Google today.
Sorry.
That was just on Google today about Musk asking Apple.
They were
for
got some money, yeah. And I was like, because iPhones are only so far, but the next, computer on wheels, next whole industry has to go on for trillions of dollars because everyone's, our employers hate us. They want to argue us. Great. They want robots there. It's just amazing. I'm going to do a talk later this year on more AI stuff and how these machine learning systems are working like in Amazon, how every order is type of robot moving around, honestly, and stuff like that. And over the years, when people don't like things, so it's interesting. Are we going to a future which is guaranteed income? And sit back and just throw a thumb if there's just but your job depends. Yeah, so it's going to be an interesting thing. What's outside there? Maybe acting like you would have two quality cars or space work. So, it's a lot of cool stuff. Yeah. A lot of cool stuff, but I was telling my son, because they claim that, by the time he goes to college, it was their first 2 years of school, actually, not the last 2 years of so, you're going to be a psychologist or robot, for AI. Or a robot repairman. I don't know. Did we see it? Did you go across?
Yep.
Did you wait?
They probably didn't have seen us.
Exactly right. You know why? Tell us why. You know why?
We are so extremely far away. It's like a 2,000 foot tall man trying to look at ants.
Well,
Not gonna happen.
they're going at 17,500 miles an hour right now.
Yeah, and
And they're
also
250 miles up. And if we can see them, they can't see us because the sun's glaring in their eyes. A group of astronomy people got wild and crazy in Phoenix, and they had spotlights in the desert.
And we're all right. Okay.
He's rambling. Oh, okay.
Jump back in here.
It's rambling about the ISS pass. So we saw this one, right? This is the next one. Oops.
General
Yeah, we did. We got the next slide. Argo AI. This is Ford. Do I hit this to make it go, or just hit this to make it go? Gotta click on it. All right, there we go.
Argo AI is a startup company by Ford Motors. It's testing 100 vehicles in at least 6 cities in the United States. Although Ford invested $1 billion in the company, it's technically still an independent venture. Argo also attracted a $2.6 billion investment from Volkswagen, but unlike others mentioned earlier, Argo AI will not produce its own vehicles. Instead, they will manufacture the self-driving technology for other companies. Initially, they plan to have the technology in fleet-based services such as robotaxis and delivery companies. Eventually, this technology would make its way to vehicles for the general public. Argo AI prides itself on reaching a level of maturity far beyond what other companies of their age have been able to do. But again, their approach is the same as with most other companies, using LiDAR alongside other hardware including ultrasonic sensors, cameras, and a radar. Argo AI acquired a LiDAR startup company, Princeton Lightwave, back in 2017. The goal is to reduce the cost of LiDARs and extend the range, field of view, and resolution needed to achieve self-driving capability in challenging urban environments. Currently, Argo AI is using Ford Fusion as the car to do their tests on. This may change in the future with Volkswagen being a major investor in the company.
Right. Once again, LiDAR has these point maps, and as long as you have an HD map in the background, you can actually then dynamically say exactly where you are. You can navigate in the world. And you can actually have extra routines that says, well, a car pops in front of me, I'll stop and stuff like that. The issue is further path planning when things change, which is a challenge. So that was Argo. And the next one is Mobileye. These guys, like I said, bought by Intel, these are the real competitors. They may win because they're doing a hybrid approach of LiDAR, machine vision, and HD maps, where Tesla's doing purely just the vision. And saying, well, this is working, but will work well enough. Start. Oh, there you go.
Mobileye is one of the most advanced competitors in the self-driving arena who partnered up with Tesla. Their technology was used in the Model S and Model X before parting ways in 2016. At the time, they were able to detect street signs and lane lines and giving stats and notifications to the driver. They parted ways because Mobileye accused Tesla of putting safety at risk by using their advanced deep learning vision-based AI in ways it wasn't designed for. Mobileye co-founder Amnon Shashua said, quote, "No matter how you spin it, autopilot is not designed for that. It is a driver assistance system and not a driverless system." At the time, this was quite controversial, and Tesla replied, according to CNBC, that Mobileye was trying to force Tesla to discontinue the development of their own vision system in favor of using Mobileye products in future hardware. After ending the partnership, Tesla scrambled to gain back the functionality it had lost, and this took much longer than they anticipated. But now these two companies are competing for full self-driving. In 2017, Mobileye was purchased by Intel for $15 billion, though it still operates as a separate entity within Intel. Surprisingly, Mobileye still outsources its manufacturing for the hardware from ST Microelectronics. It's important to remember that Mobileye, like many other companies working with self-driving technology, does not make its own cars, but rather provides the necessary technology and hardware to car manufacturers. Their technology currently resides in about 60 million vehicles with ADAS, as long as these vehicles have the full sensor set and chips for full self-driving and a mobile connection to send data back and forth from Mobileye's cloud. This, of course, isn't the case with some of the older vehicles their technology resides in. Nonetheless, they're currently able to collect almost 4 million miles of data every single day. One of the key breakthroughs that Mobileye has accomplished is crowdsourcing HD maps. This is something that Tesla does not use because the main challenge with maps is its scalability and keeping it updated at all times. You see, if the environment changes, for example, there's construction, a road closure, or an intersection changes from traffic lights to a roundabout, the map would have to be updated. According to Tesla, this is unrealistic, as updating every possible road across the entire country or the entire world would mean that every minor change in the environment would have to be updated almost in real time. However, Mobileye tries to get close to that by using the current vehicles on the road to map the road itself and send data back to its servers. The images that these vehicles accumulate are processed by Mobileye algorithms with the goal to create a highly accurate road book that contains an average drivable path within 3 to 10 centimeter accuracy of every road and every lane in the world. Now, transmitting such vast quantities of data would not be possible due to cost, but Mobileye has developed a system that only extracts the key features that it needs to create an HD map. Overall, Mobileye says that it ultimately intends to use the maps as a redundant system to supplement its vision system, but the maps are created using the vision system in the first place, so they're not entirely independent. However, this does put Mobileye ahead of competitors such as Waymo, who rely on HD maps but don't have access to them aside from creating their own. That said, relying on HD maps is more considered automated driving as opposed to autonomous driving because the vehicle can't really figure out what to do in the absence of the map. For instance, a new area or a changed environment. In short, this solution works well until it doesn't, and Tesla's solution won't work very well until it does.
So there's several major points raised there, right? Data is the answer. In the case of the Waymo, Google guys, they have their HD map, they've got their geofence, now it's a 100-mile thing in Phoenix, and they got to stay in that area, and they work well in that area. But it's also not raining and snowing and stuff. Which LiDAR has issues, because LiDAR is light, right? And even through fog and stuff has some issues where radar can be better, penetrates, but then radar is also kind of, not so good, not as high definition. And so you lose things, and that's another issue why Tesla just recently dropped radar in favor of more vision in maybe your car. You send updates all to see if you have the right software. So basically, Mobileye is playing straddling the fence, as they say here. These are later videos. I'm just trying to bring all the good stuff up here up front before everyone gets too tired and wipes out here. But basically, they've got the HD maps. They also have cars, and once again, Mobileye is not vertically integrated like Tesla. Tesla builds a computer, the software, people, it's perfect, right? Mobileye, well, we'll make something, but hey, you're Ford, or hey, you're not GM, but you're Hyundai, look about, their software. Then you have to integrate it to your sensors, and if there's not quite right, there's issues and stuff like that. So, but they're also having those fleets, if you will, of cars out there now start to give data back to Mobileye, so they can start updating their HD maps. So a guy drives down the street, sees a cone on the road, well, the car sees the cone, traffic cone, it goes back to Mobileye and they can update their map. So the next guy comes along, we know that, go around that cone, stuff like that in their path planning. So that's where everyone else doesn't do that. They got the HD maps and things changes. Oh boy, we got to try to figure out how to handle it when it breaks. And AI tends to be a technology which works well until it breaks. Then it breaks badly, right? It's very brittle. Where with using, and of course, the technology we'll talk about is some neural net and deep neural nets in the back end. They kind of learn these things, and they learn lots and lots of stuff, and they can kind of adapt around these things. So that's where the help comes in there. So Mobileye might be a potential winner because they're picking up data, sending it back from the newer cars, not the older ones. They're not quite at the level of data that Tesla's getting. If they're getting, Tesla's getting 10 times or 100 times more per day than even Mobileye's getting. So once again, those with the data at the edge cases, are going to win. And then, of course, here's Tesla. See there.
Last but certainly not least, there is Tesla, and they have over 1 million vehicles on the road collecting data for Tesla's deep learning AI. It's hard to tell how much data they've collected so far, but a quick calculation shows that they're able to collect 1 billion miles of data each month. How did I arrive at this number? Well, if we assume that each car drives approximately 1,000 miles per month, multiply this with the number of cars Tesla has on the road, which is over 1 million, and you get 1 billion miles of data collected from the existing Tesla fleet. That's 35 million miles of data every single day, which is what Waymo has collected so far. Nobody comes anywhere near that number, even when you combine them all together. And remember, we're talking about real-world miles, not simulated miles. Tesla also uses a simulator to teach the AI, but as I've said before, real-world data is much more valuable than data from a simulation. Now you might be wondering, how is Tesla collecting all this data? Tesla has a feature called shadow mode, which runs in the background when the car is being driven by the driver. How it works is it makes decisions in the background without affecting the driving and then compares those decisions to the driver's actions. This is great in every corner case that would be difficult to predict otherwise. Technically, it's learning from humans and their driving behavior. This data is then sent to Tesla's artificial neural network, which will get labeled and then fed to the entire fleet. Basically, the more Tesla vehicles drive, the better their self-driving gets. This approach is genius, as Tesla does not have to pay billions of dollars to test their self-driving system to collect data. Instead, Tesla is getting paid while collecting all the data for free. Tesla uses 3 forward-facing cameras, from which one on the left and one on the right work like human eyes for better depth perception. It's the same effect as when you cover one eye, which will limit your depth perception and making it harder to estimate the distance of objects. The camera in the middle has a longer focal length, which allows the car to see farther ahead. They also have a forward-facing radar that works in conjunction with the cameras to help measure the distance of objects. Tesla also has 5 more cameras around the vehicle to get a full 360-degree field of view around the car. Ultrasonic sensors on the car help in detecting objects in close proximity to the car, which is very useful when the car is parking itself. So when we compare who has the most amount of data for their self-driving technology, Tesla has a clear lead while others are nowhere near them. And while others are still determined to use LiDAR to create a 3D map of city roads, they fail to address the changing environment in which we live in. Roads don't always stay the same, and there are a variety of scenarios that can confuse the car and disable navigation. While LiDAR does work in real time to scan the surroundings for obstacles, it navigates using an accurate 3D map of the environment. But anytime there is a change in the environment, the 3D map has to be updated. But a vision-based system can easily overcome this. Tesla Autopilot already runs smoothly on roads that it hasn't even driven before. It's even able to navigate through construction sites, though there are a few corner cases that still require some work. The fact is that the car can navigate through challenging and new environments. When Tesla vehicles drive on autopilot, they navigate through the environment like they've seen it for the first time, similar to how we humans drive when we drive through new areas. As Elon Musk has said several times before, the real world is very messy, weird, and unpredictable. Teaching an AI to understand the difference between a cat and a dog, or a plastic bag and a tire, sounds easy to us, but an AI has to learn this from scratch from a set of 2D images. But over time, as Tesla gets more and more vehicles on the road, the amount of data it can collect will grow significantly, which can enable the AI to learn much quicker. The current iteration of Tesla's self-driving software can recognize traffic lights and stop and go accordingly. It can also recognize some traffic signs, traffic cones, change lanes on its own, take the right exit on a highway, and the list just goes on. And this just continues to improve over time with over-the-air updates. Tesla also creates a 3D reconstruction of the world around the vehicle just from the cameras alone. Here's how Andrej Karpathy, the Director of Artificial Intelligence and Autopilot Vision at Tesla, explained it on the last Autonomy Day.
So here's a video going down, I think this is San Francisco, of a Tesla. So these are our cameras, our sensing, and we're looking at all, I'm only showing the main camera, but all the cameras are turned on, the 8 cameras of the Autopilot. And if you just have this 6-second clip, what you can do is you can stitch up this environment in 3D using multi-view stereo techniques. So this is the 3D reconstruction of those 6 seconds of that car driving through that path. And you can see that this information is it's very well recoverable from just videos. And roughly that's through process of triangulation and, as I mentioned, multi-view stereo. And we've applied similar techniques, slightly more sparse and approximate, also in the car. The point that I'd like to make is that visual recognition, and very powerful visual recognition, is absolutely necessary for autonomy. It's not a nice to have. Like, we must have neural networks that actually really understand the environment around you. So as an example, on the left here, is that a plastic bag or is that a tire? A LiDAR might just give you a few points on that, but vision can tell you which one of those two is true, and that impacts your control. Is that person who is slightly looking backwards, are they trying to merge into your lane on the bike, or are they just going forward? In the construction sites, what do those signs say? How should I behave in this
LiDAR
role?
can't
The
read that.
entire infrastructure that we have built up for roads is all designed for human visual consumption. So all the signs, all the traffic lights, everything is designed for vision. And so that's where all that information is, and so you need that ability. Is that person distracted and on their phone? Are they going to walk into your lane? Those answers to all these questions are only found in vision and are necessary for level 4, level 5 autonomy.
So there you go. So LiDAR, which Elon Musk says it's a crutch, well, it is. It's getting people to show off really cool. But LiDAR, like I said, doesn't see that sign and read it. Tesla is reading it. Mobileye with LiDAR, with vision, is reading it as well, but now they're also kind of adding LiDAR to their mapping too. So they're both racing there. And like the gentleman said before, I think, the one who, Tesla will be harder to get there, but once they get there, boom, they're there. Where Mobileye, where they're doing both techniques, we got this model, HD model, and our LiDAR, and we're also watching and updating this model using vision to kind of start read signs and stay in lanes. They're slowly nipping away at the problem, and as they find new issues, they kind of slowly nip away at the problem, get closer to the solution. Where Tesla is doing something more called end-to-end learning. We'll talk about that too. Where if you give enough data, the neural net can just kind of figure it out without you telling it what to do. Scary, amazing. And if they win, boom, they're there. They blasted a fleet, and all of a sudden everyone has full self-driving, and all the other guys are like, oh, we're getting there. So it's a real interesting multi-billion-dollar race for a trillion-dollar industry. Very, very interesting. Just quick and dirty, what's happening? We have sensors, right? We're talking about all these things like the LiDAR, the GPS, cameras, radar. And radar, by the way, is neat. It sends out through the fog and snow, bounces back, you know something's there, but it doesn't have very good definition. And when you're going down the road, radar picks up things like manhole covers and bridge abutments and other strange things. It doesn't know if things are coming in and at you. So there's a lot of issues with radar, which, by the way, because Tesla got their vision so good, called Tesla Vision now, they've decided, well, we've got this, what's it called, sensor fusion integration issues. Radar says one thing, the vision says the other thing, and they decided radar is just not reliable enough, we're going to drop that. So Tesla was doing those driving maneuvers, not with a $75,000 LiDAR, which nowadays the price has actually dropped down to about $1,000, price of the car. They're using a $1 to $10 camera in the car to make those, to navigate. As a matter of fact, they're just using one camera. The stereo vision doesn't really matter too much. George Hotz, the guy who you saw before, the ComAI CEO, who broke the iPhone and jailbroke that, and he's a hacker and stuff, and he decided to grow up and actually make a company. He said, no, let's do AI. So he went in that direction. His solution is a cell phone. You buy it for $1,000. You put it in your car, 2016 and older, and it does almost the same sort of stuff versus $10,000 of full self-driving with Tesla. It's not as good as Tesla. It's not ever going to be as good as Tesla. But it does at least level 2 stuff, and it's learning more and more. He's also playing a game where he's getting data from the fleet, his customers sent back to him. But because it's not vertically integrated into your Model Y or Model 3 or Cybertruck, yay, someday, it's going to be in your Pinto or whatever car. So there's issues, and they have to pull back and say, well, we're going to talk to the car, but there's delay issues, but we're going to drop back a little more and be a little safer because we don't know how the actual car works that you're putting this into. And we assume it's about this latency and such like that. So anyhow, so that's just sensor we're talking about. But then when you understand what's going on, then you got the sensor fuse, right? Radar said this is here, the vision says that. The LiDAR says you're this far away exactly in millimeters. How do you put that together? And then, of course, we're talking about the world model, high definition maps, right? That's in place. Then once you sensed your environment, you had perception, then you have to act. Right? Behavior generation, path planning. Am I going to go forward? Am I going to stop? Am I going to go into a tree? Am I going to go away from the tree? Am I going to see a person stop until I go across? That sort of stuff, right? That's how you're planning. And other functions, lane keeping. Once you know what you might want to do, what should you do? And of course, then you talk out and control the vehicle. And I guess nowadays, I think 2016 older cars have the CAN bus interface. You're steering by wire, you're accelerating by wire, you're braking by wire. It's just sending commands out over this bus to control the car. Which means, if someone actually had the right hacker next to you and they had a phone or who knows what, then maybe they could control your car and take control away from you. Something scary. Which is true because these guys now have a lot of encryption and other security levels to override this, so people don't take over these cars now that the issue's been raised. And the actuators, like I said, the brake, the throttle, transmission, steering, and of course safety stuff. Oh, safety stuff. Tesla had a lot of issues, right? You may have seen recently, car and driver decided to be useless and meaningless, and show how you can break Tesla's car and drive or Tesla's auto self-driving system by putting weights on, blah blah blah. And you can sit in the back seat, da da da. That doesn't seem very smart to me. And I show people how to hurt themselves. And Tesla's self-driving is basically touch the wheel every once in a while, make sure you're there. All the other guys said, "Ooh, we don't like to be sued." So GM and Ford and everyone else said, "Never going to have infrared lights shining at your face, and little cameras watching you. So in the nighttime, it's on. It's watching your eyes. It's watching your face, watching where you're moving, watching your eye movements. And if you disengage, the car tends to say, 'Hey, wake up.' And if you don't wake up, then it'll pull over and stop." Tesla just recently did this too. They said, "Well, we'll put a camera inside the driver compartment because we're afraid that if we ever get self-driving, have robo-taxis, you're going to have your car go out and make money for you and rent it out as a taxi. Someone makes a mess. We want to take a picture, make sure you know who did it." Yeah, maybe. They're doing it just like GM and Ford and everyone else. They're doing the driver monitoring, which is important. And there's another whole talk there we could go on with complacency. And people, after a while, even though we're supposed to take control of these systems, do you get a little lazy and look around, And you saw GM's Cruise, right, Super Cruise on the steering wheel, at a green light right in the steering wheel. It says you're okay, and if it starts flashing or shakes, try to get your attention back so you take control of the car. And we're going to have issues. People are going to just zone out, and like I said, early on, people misunderstood what autopilot is, which is not full self-driving. It's automated driving. It helps you. It's an assistance system. And people are out in California sleeping in their cars, laying back, and the chips are pulling up next to them with flashing lights. Hey, wake up! And people are just driving. The cars are driving. Dangerous stuff like that. So, like I said, I mentioned before, end-to-end with neural nets, instead of training for specific cases, and that's exactly where Tesla went initially. We're going to look for exactly this case, and that case, and that case, and then we're going to try to fuse them together. To now saying, well, we're going to kind of eat that old code with some new neural network code, which is going to just kind of give it data, and it's going to learn generically how to do some of these things. And it's seeming to work quite well. And this is what's called end-to-end, which doesn't work for every problem, but it's another new approach people are using to train their cars. Once again, I throw out the term AI. What is it? Well, it's a bunch of stuff. It's a whole discipline, right? And we're not dealing with natural language processing or speech, or like my old days, the GoFi, good old AI expert systems and planning and robotics, but self-driving cars, they're robots. They're using vision, looking at image recognition, right? They're doing machine learning, something called deep learning, which means how many more nodes in your network. Some of these networks are just huge, and there's a certain amount of magic to this. There's even a new discipline called explainable AI, where you try to watch into your network where things happen, and you expect things to happen, so that we can sort of explain it. Because most of the times you feed the data in on the back ends of the result, and the magic sort of happens. We don't really know. You have thousands of nodes, and basically you're feeding forward information, and it's feeding back what's called I'm trying to blank. The actual activation values, the weights change. It's called backpropagation. A very simple technique. And we couldn't do this back when I got my doctorate in 1990 because the networks are very small. They had a lot of high-end computers. But now, Moore's Law, everything is growing exponentially. Technology does that. We have these great computing systems. And on the side, we have a space shuttle computer out back there, and then we have our cell phones, which are like, 1,000 times more power than that big block out there, right? So as the technology increases, neural nets became viable in 2005-ish time frame, 2007. And this whole industry just kind of took off. Once again, we have artificial intelligence, which encapsulates machine learning, which encapsulates deep learning, if you will. And then in machine learning, deep learning, we've got something called supervised learning, unsupervised, and reinforcement. most of the techniques being used by Tesla and others are they're labeling their data. They're saying this is real truth. Supervised learning. They're trying to get to the point where they can say, well, we have so much data, we're hiring so many people to label this stuff. The system will let it mung for a while, and it's kind of figuring things out itself, sort of classifying things by itself. This is called unsupervised learning. And another billion-dollar industry of Tesla. Remember, Tesla's not a car company; they're a technology company. Watch out, Apple. Right? Their whole supercomputer they're building, their Dojo system, might be something that they'll share and sell out, just like Google does, just like Amazon AWS does. Right? Those are the other major players, and of course IBM and Microsoft too. So. Okay, life cycle of a machine learning project. Define it, collect lots of data, train the heck out of your model, and then deploy it. So that's what's kind of happening. These are called pipelines. And you basically have a model view. Model view, that sounds like LiDAR, HD models. And you also have the data-centric view. And that's the Tesla kind of angle, if you will. And basically, as you get more and more data, a few sparse points, you kind of fit the equation or the curve, more points, hey, all of a sudden it's a little better. But you can play games where you actually just tweak the data sometimes and make it so, this is truth. When these data points happen, we're going to do this. And that might be like accelerating the car, braking the car, versus speed and stuff like that. I mentioned, and then real quick, deep neural networks. You kind of get a lot of data and sort of from the input to the output with usually, well, it could be either reinforcement. I'm sorry, it could be any of the three actually. It could be those three learning techniques, which was supervised, unsupervised, or even reinforcement. And it kind of figures it out. But limitations end to end, huge amount of data, difficult to improve or modify the system. If you find an update, you got to rebuild everything again, new feature, build everything again, new feature, build everything again. Tesla's doing this. They have a huge supercomputer, the fifth fastest in the world, they claim. But at the end points of their model, they're trying to just do specialized things, so you can just kind of localize the fix without rebuilding the model over and over again. And also, once again, difficult to validate because the magic is sort of happening. How much detail should we go into? For actual scene recognition, there's the AI researchers have used something that University of Toronto did way back when, called ImageNet, and these are basically 15 million labeled high-resolution images in 22,000 categories. This is research data put out there, and you can take this and use it. This is all basically full of pictures of dogs and cats, but Tesla's using it because there's dogs and cats on the road. There's cars. Well, the bottom line is there's something called transfer learning. You can actually take some of these training models and tweak them a little bit and use them again to not only analyze dogs and cats, but cancer cells, cars, buses, things I just kicked over here. So convolutional neural networks. Yeah, basically, what are we doing? We're doing matrix multiplications here in additions. And so basically we have this matrix XY of pixel of a picture, and we have a small little filter kind of goes across and convolutes. And on the back end, what comes out is a pattern which might look like an edge. For edge detectors. We see an edge of a highway, an edge of a face, things like that. So CNNs are used basically for all this image processing that these car companies are doing. And this is just, raw data, low-level features, until it finally comes to a network to high-level features. Does it classify and say, this really is a cat, or this is a dog, or whatever, or this is the face of somebody? I'm not even going there. Segmentation. As a paper. Segmentation allows you to actually take these scenes and then put what's called bounding boxes around them to segment them. Car, human, these are colors, what it is. Building, it's a building over here, is that right? Purple's the road, pavement is blue. So, but that's what the computer sees, and then you gotta make sense out of that. And that's not even the highest definition either too, so there's issues there. But that's some of the tech under the covers. I'm pushing a button and nothing's happening. Oop, LiDAR. These are these sensors, which are basically lasers spinning around at, sampling tons of stuff. But once again, they're expensive. They've come down in price. Even some of these now are even as low as $500. But a camera's $10. So, but that was a real drawback. Can we have these big blobbly things in our cars running around? It looks like junk, yeah. Tesla, just cameras, now not even radars, just that and the backup sensors, which is what's that called again? And the bumpers. I'm drawing a blank. But the bottom line, this is LiDAR. It spins around, gives you your mappings, so light's shooting out, 360, and it's reflecting back to you. You get snowy, foggy, doesn't work as well, just like light. Those lasers. Radar will penetrate that, but radar, when it bounces back to the fog and stuff, isn't good high definition. It has these lots of false positive returns, unfortunately. Quick overview of the good and bad of LiDAR and vision. Expensive. Doesn't work in bad weather very well. Power hungry. It's ugly. I mean, the Tesla cars, the Waymo cars, the little light on top there, that's a radar dome. I don't know. But if Waymo and Google want to make money just being in geofenced areas for old age homes or certain communities, like they're driving around Phoenix, 100 miles square, that's pretty cool. That's an industry, and I think that's a real industry which Tesla wants to get into, but may not get there because these guys have been doing it for the last 5 years already. Right? They got radar in front, LiDAR in the front, LiDAR on top, LiDAR over here. LiDAR is over here. A bunch of cameras all around the car and stuff like that. But they only drive in fair weather because they don't get sued because things will happen. There's Tesla. Where's those sensors? I don't know. I heard there's a Tesla outside. Bottom line is sensors here, camera to pillar, 3 cameras up here, radar in the front, but now they're disabling radar because the new technology just rolled out about a month ago, so they don't think they need those anymore. Backup camera, which is camera right in the back there. So LiDAR is everyone else. Tesla, no. LiDAR, radar, I just mentioned about radar. It's got issues and goes through fog, but it's not high definition and can give false positives. And then we have to fuse that sensor fusion in the back end. LiDAR, really sharp. Even high resolution radar, there's something out there, but then all of a sudden metal reflects and you have a manhole covers and other weird things, and just false positives come back and it confuses the system. That's what I'm saying here. Radar's cheap, camera's cheap, LiDAR expensive. It goes down the line. I never mentioned those things. If cameras could learn to measure distance. Now, last video I showed where Andrew Kopernik was showing a 6-second video where we had 3D models, right? From Vision, he built a 3D world, right? He spun it around. We saw that, right? That is the death of LiDAR, because now your $10 camera did it versus this, $500 LiDAR, and then they got fused together. And as Elon Musk always says, the best part is no part. And if there's less sensors, the better. And so that's where it's sort of going. And vision and brain. So if you actually see things, you got to actually understand, and therefore you need more computing power in the back end, and you need more AI smarts, if you will, a modeling of your world. And once again, more data, varied data, and real world data. All these companies with LiDAR and stuff, they're doing modeling and they're simulating stuff. That's good, but there's issues that pop up. One of the things, I might have to come up here. Oh, there it is, the bike. Tesla, for the longest time, was chasing the moving bike. Because, what the heck? It's on a car. They're watching, it's moving. They're not supposed to, it's got to stay away from it and stuff. They couldn't figure out, why is this thing floating? It's on the back of a car. So all these real-world situations, they have to learn, and sometimes in these simulations, they're just not there. You can't think of them. And Tesla goes to the fleet. They said, well, we need to have some examples of construction. And they go to people who have Tesla cars, who they're watching all the time. And they say, hey, cars, 1 million cars out there. Nowadays, 1.5 million cars and growing. I need the samples. And they just kind of sample what came back to them, and they can pick out stuff, and they can start building a new model based on these new samples. Animals in the road, deer jumping out, stuff like that. Cows, maybe horse and buggies, who knows. What is this one? This is the debris, right? Is it a tire? Is it a bag? LiDAR bounces off and says, yep, I see it. What is it? I don't know. It's there. Okay, avoid it. That might be good enough. But if it's something might roll, and actually use vision and identify it, you can do other useful planning possibly to avoid such things. So, Tesla Vision, basically in version beta 9 now, which you have 2,000 people around the world, or actually around the US, testing this. And that's the other issue. Should Tesla be doing this? Are we endangering people by having beta software out there where people are kind of let cars drive themselves? Maybe. But all these car companies are not just doing stuff and throwing it out there. Go try it. They're simulating in the lab. They're having their engineers run it and test it. And so after many iterations, they're slowly releasing it to the world. They have the cameras, like I said, long distance camera, short distance camera, and the idea of stereo vision, turns out George Hotz saying doesn't matter. Stereo is important to go close to pick up a bottle. But you get out far enough, a couple of 10, 20 feet, one eye is just good enough. It just works fine. And as a matter of fact, Tesla's cameras aren't really true color. They have 3 colors returned, and they're kind of like a grayscale kind of weirdness. Seems to work even best to avoid sun and that particular frequency of light they're playing with seems to work better to get further distance vision as well. Here's their cameras. They start to stitch stuff together, 3D plus 4D, which is time. You can predict paths. They can predict some paths. Some of the future type stuff, how far can we plan into the future, that's going to take more computing power and some other tweaks and turns, but they're building better hardware for that. Version 4 is coming out. We talked about this, a scene generated, looks almost like LiDAR, doesn't it? It's all vision. You see a shadow in here, and you see 3D stuff. You can actually estimate ranges, and they came in very close. They used their current LiDAR system, they used their current radar and vision in testing to develop this, and now they said, no, we can just drop the radar because it works so well. There's the cameras. This is the backup cam. That's usually, see these weird kind of colors. This is more of a natural color. That's, they basically use these cameras, right? These are the 3 in the front, 2 in the side pillars, shining forward, 2 in the side fenders, front fenders shining back. Get that view around the car. They've identified triggers when things blow up. So basically, they're pushing out a model of the world to everyone who was a Tesla. And they're shadowing you. They're looking over your shoulder as you're driving. And all of a sudden you hear and you stop and did a weird thing and turn. And if it's a weird trigger, one of the things they're looking for, they'll actually take that vision, that snapshot of what you did, and with everyone else, and they'll start looking at that, and they may have to relabel that and say, here's something new to train on, something we never thought about before. And then, of course, they've gone, in the last iteration, they've been 7 rounds of all this munging of data, 1.5 petabytes. I mean, each camera view is at 36 hertz, frames per second. We're like, 8 million bits of data per second or something like that coming from these cameras. But to make this all work, like I said, even with the end-to-end learning, it's got to have large data sets, clean, properly labeled data. That's just a general thing for machine learning in general. If you label a car or you label that coat to be that, and I say that's a frock, I don't know, it won't match, and the system gets confused. You have to have consistent labeling. So that's why they actually hire a lot of people to do this. And now the system is actually doing it automatically to some level. And it's hoping that's called vacation mode. If the system can do all this pre-labeling, their staff of only 20 people, by the way, can go home or take a vacation. Their staff of 20 people doing all this work versus the hundreds of thousands for billions of dollars being spent doing all the other efforts for people to try to catch up. Every other car company. Tesla's advantage. Their pipeline, deploy it, see the problems, do something to tweak it, unit test, make sure they didn't make a mistake. It comes back, they relabel it, retrain it, push out again. Right? For Beta 9, came out just 2 weeks ago, 3 weeks ago. They had 7 iterations of this, and so with each release, it's going to get better and better, more edge cases. But you might ask yourself, will they find all the edge cases? Probably not. But if it gets better and better, maybe it matters less and less. Will it really be level 5 autonomous driving, fully autonomous? Maybe not, but maybe level 4, maybe level 3.5. I don't know. Might be good enough. On their hardware, they have 2 CPUs, if you will, neural net engines. So basically what Tesla's doing is taking this big lump of data from the world and they're breaking out and analyzing it. And as you get to the lower pieces down here, these are specialized detectors, stop sign detector, pedestrian detector, animal detector, things like that. And they initially were trying to build these little detectors first and try to put them together, and they just failed. And that's what we went back to, well, maybe this top-down approach seems to be working out a lot better. And then they take all the data, and they mung it on this small PC that goes on your desk. Wait a minute. This is the 5th largest supercomputer in the world, using their, like I said before, their competitors' chips. NVIDIA, right? The A100. A100 is you'd buy in a 4 CPU lump for $65,000 for a 8 one for $140,000. I don't know. And they've also these all linked together, and they have very fast, NVMe, very fast data. So this is a big data analysis problem where you have all this data and money, chop, getting results back, and going through all these neural nets as you go through the various layers and recurring back on itself again. So huge computing infrastructure. So they do all the heavy lifting at home because they source it from you or driving your Tesla car. And they compress it down to a smaller lump and they stick it into your car then. Dojo, that's the other potentially billion-dollar industry they're going to have. Selling out computing power. This is their chip, where their board has 2 redundant AI chips. How's that? Inside those chips, they have graphics processing units, neural net processing units, a lot of data, a lot of memory very close. I can swap things real fast, and they're only, I'm drawing a blank. The actual X by Y size of the matrices they're doing. So basically, they made specialized hardware. It's called ASICs, right? Since they're all vertically integrated, they built it. They sent it up to Samsung. Samsung built the chips for them. Everyone else doesn't have this. Everyone else has NVIDIA with graphics cards. NVIDIA has a solution also, but NVIDIA's solution is for AI research, self-driving cars, automation of your pharmacy, automation of your farm, automation of your... So NVIDIA is out for the money. They're making something that's really cool, but it's not specialized for power, speed, size. So everyone else is using these bigger systems. And if they want, this technology is not amazing. I mean, it's not even patented. Not like I said, patented. Tesla has open patents. But the bottom line is, it takes $100 million to build something like this. And NVIDIA's going to not do that unless GM or Ford comes up and says, "Hey, we're going to get 100 million chips from you." Then NVIDIA will say, "Okay, we'll build something like that." That's going to take another year or two, and so now they're just behind. Okay.
I know we've got some smaller kids here that probably go out
Juice.
So
Yeah, I can finish up quick. I just kind of.
those that would like to, Saturn is in one of our schools right now. People will be there soon. Well, they'll be there through the night, so you're not going to miss it if you stay. But I just know that
We'll be here too.
people with some younger kids may want to take a shot of that. So, but press on.
So, and like I said, I've got tons of data. So if you want to sit and listen, I'll show you all sorts of crazy stuff too. And this is just an example here of just radars falling out, being confused, and the vision system not. And they decided, wow, radar no good. Let's switch to vision only. So, and then that's basically the summary of what I said. So thank you for the talk, for coming, and I got a bunch more stuff. But
well, many people know all about Tesla's quest to create.
Oh, we just talked about him.
And now for Mobileye. Mobileye was started in 1999 by Amnon Shashua, a researcher at Hebrew University who turned his academic research on autonomous driving into this company. The company, based out of Jerusalem, Israel, started by making hardware, the IQ chip, which has gone through a number of iterations since then, as well as the proprietary image processing algorithms to run on the chip. The company added their technology to autos from BMW, GM, and Volvo, and in 2014, like I said, they partnered with Tesla, releasing their first self-driving technology in Model S's in 2015. As mentioned previously, a fatal accident in 2016 led to a breakup with Tesla in July of 2016. In 2017, Mobileye partnered with BMW and Intel, and also in 2017, Mobileye was acquired by Intel for $15.3 billion. While Mobileye has partnered with auto manufacturers, they are obviously independent of them. Currently, Mobileye is demonstrating autonomous driving capabilities that are in the same category as what Tesla is doing. Auto lane keeping, auto lane changing, and some ability to navigate on streets as well as highways. While Mobileye has traditionally primarily been vision-based and, of course, radar and sonar, they are also open to LiDAR and are using that technology more and more over time. The upcoming Lucid Air, for example, will have a built-in LiDAR system that can only see out the front of the car, not like the ugly balls on top of Waymo cars that can do 360-degree LiDAR. In fact, the Lucid Air is going to have 13 outward-facing cameras, front-facing LiDAR, front-facing long-range radar, 12 ultrasound sensors, and an internal camera for driver monitoring. So it's going to be quite the suite on that car. And all of this is supported by Mobileye's IQ4 SoC. It's possible this might even now be the IQ5 chipset, as that is coming out shortly and will supposedly support L5 autonomy.
So yeah, just to show that Lucid Air is going to be a very high-end car. So for $180,000, maybe you do have all the sensors. They're just throwing everything on the car, hoping that they're going to get it right, and they're going to pitch with Mobileye. So there's the computers, like I said before. Some of these things I already said before, so I'm just skip through to the end. What might be fun to see is, and like I said, they're sourcing from we've already talked about how Mobileye is sourcing from their new fleet of people. and getting these HD high definition maps updated because they're driving around
Cars with
and responding back. Com AI, this is kind of cool. The cell phone. Let's start.
George Hutz is the founder and president of Comma AI, which is building vehicle automation technology based on machine learning. And thank you so much, George, for being with us today. I guess I want to start off with your slogan. Comma's slogan is "Making Driving Chill," which I think is super awesome. We are big fans of Tesla Autopilot and stuff on the show. I'd love to know more about Comma AI. Like, what essentially is it? How does it work?
Well, so first off, to differentiate, our slogan is "Make Driving Chill." Maybe Tesla's slogan is "Look at this crazy feature." It's similar to Tesla Autopilot. We think of Autopilot like iOS. Apple is vertically integrated. You buy the iPhone, it comes with iOS. Tesla is vertically integrated. You buy the car, it comes with Autopilot. We're like Android. So we work across many different manufacturers, just like Android works on Samsung and LG and Motorola and Google Pixels. We work on Hondas, Toyotas, Volkswagens, Hyundais. It's a box. Buy it. It's now $1,100. It was $1,000. Prices go up. And you put it on your windshield. You connect it to the car, which connects into the CAN buses. And then it looks at the road, decides where to drive, sends the commands, and the car drives there.
So, I mean, essentially, it's I assume you've taken like a cell phone and maybe made it to work for what you need. Like, is it essentially a cell phone for the hardware part?
We use cell phone pieces. So cell phones have this incredible economy of scale. If you can reuse parts of a cell phone, it's economically advantageous.
So basically, they are using a cell phone. Of course, they only have one camera looking forward. But instead, if we go to a cell phone manufacturer, say, well, we want some stereo vision, they'll make it for them, I'm sure. And they also have one of the better driver monitoring systems that looks backwards. Even Tesla, someone hacked some of Tesla's code and was watching when people are seeing the car, what the face expressions are, and Tesla actually has about 60 parameters, facial things that you're looking up, down, stuff, looking at cell phone, things like that, they can identify for safety. Anyhow, but George Hopps say he's got the best driver monitoring system right now. Then there's a guy who drives with it. Maybe I'll just real quick to see it actually does work. There it is, just kind of,
Hey guys, it's February the 27th, and today I thought it'd be fun to go just do my normal commute into the city, and we'll see how OpenPilot does.
It drives the wheel, but you can actually yank the wheel back, control back.
This is just right
disengaging
outside my
from
house, so
Autopilot or Comma AI's system, just step on a brake.
Yet, but let's go ahead and turn it on.
Cruise control.
And then just hit set. So now OpenPilot is engaged. I'm just going to up the speed. And here I'm just going into a turn lane.
It needs speed too. Sometimes it doesn't work unless you're over 45 miles an hour too.
Car stopped ahead.
It's meant for highway type stuff.
We're actually going to up it over here. And it's doing all the braking, stopping behind this lead car.
Pretty cool.
So basically,
so that just shows that it works. So, and then just to close out and show you a video of Waymo acting bad. Their supercomputer. Oh yeah, Neo now
on the 9th of January
hooked up with NVIDIA to make their supercomputer will be better than Tesla. Well, Tesla's going to go and
anyway. Let's
chips. Tesla's going to go and build a whole wafer now, which is a whole supercomputer inside the car, which is kind of cool. Who's going to win the race? This is interesting. Waymo, because they're already doing it, self-driving in limited areas. They're doing it, so I think they're winning. Other robo taxis are going to be Cruise, Argo, right? Zoox. These are guys who are doing stuff now in limited areas where it doesn't snow and doesn't get wet. Out in the Southwest, San Francisco, stuff like that. Tesla and Comma AI, they figure 5% winners because, well, they're going to have self-driving, but that's, the robo-taxi fleet might take a while to get there. It's going to be harder because the other guys are already there in that limited high-definition model world that's geo-fenced. The general solution is going to be a little harder, so they'll be down the road. Mobileye, they might win because they have more cars to go into, right? Where Tesla has only 1.5 million cars out there. Mobileye has 40 million cars because they did it over multiple years now, and any vendor works on any car, right? China. This is the other takeaway for the talk. My dad worked for Bethlehem Steel Corporation. I couldn't buy a foreign car. Buy American back in the days, back in the 70s and 80s. And eventually I bought a Honda. And the auto manufacturers said, hey, let those Japanese guys have the low end of the market. Then all of a sudden Honda and Toyota took over. I mean, boom, right? China has 300 EV companies right now. The government says you will cut down to 150 by the end of the year. Okay, so. But there are a couple they like, and if China gets their act together, and they also have their own AI companies, which I'm not tracking, but I'm sure they're just as good, they come here, they start dropping off cars cheaper. It could be interesting, just on EV side, it could be an interesting battle between U.S., which is maybe Ford with their, F-150, like maybe if it comes out 2 years from now. So the bottom line is China's coming, and we should be aware of them. Also, like Argo and stuff, Aurora, they're looking at trucks, and that's the other big thing, automation, right? If you want to automate trucks, just driving highways, get off on the right exits. Now, even that last part going to the actual dock, who cares? But the long haul stuff, that could help a lot, and even automate stuff. And even Tesla's looking at doing this with caravans, maybe 3 trucks following each other. In the front, it could be a self-driving truck, so who knows? And even small delivery robots. Remember Pizza Hut, the Noid? Well, they're making ads about this one now, but this is actually Neuro, another company who's been certified to have these little tiny autonomous vehicles drive around the roads. And they're, once again, in the sunny areas right there where it's no problems. They have LiDAR, just same sort of solution, right? And they're delivering pizzas and stuff like that. And Amazon's coming big time, too. Amazon wants to play this game, and Amazon's even do drones. And those who fly drones in the future years, next year and stuff, might start getting grief because Amazon's going to try to actually launch a drone fleet. It'll be over on your Prime and things will be flying to you. That's kind of fun. So, or maybe someone else wins. We don't know yet. Who knows? And of course, Tesla. This is the last one just for fun. Here's Waymo in Phoenix, and they're trying to make a turn. You hire a ride. You sit in the back, and you got like a taxi cab, like glass across there, and the car's up there, right? And Waymo basically with their self-driving is assisted. They've got teleoperators in the back who can dial in and help you and do stuff. Or the fleets of people with cars come out and help you. If you get stuck, they get out, they open the door, and they drive for you. And they're just like a mile or two away. So this guy's trying to make a turn, but unfortunately over here we got cones to the right construction, something that's not in a normal model.
Oh.
And this is quite funny.
It's, okay.
Cascading errors.
There we go.
Car actually looks like it is on its way.
So he's online with the help lady.
I don't think it was supposed
you
to
call
do
in case the car gets stuck.
Oh no.
So it made a turn, but it went between the cones, got stuck.
Did it pause again? It looks like it did.
Oh, now it's blocking the entire road.
Lower right, you can see the picture.
Okay.
Kind of like the lanes here. And
that's.
So is this safer or is this lead to more danger? But it's been running for years, and this is their prime time right now.
It's no longer stranded. Now it's blocking it.
The CEO of Waymo did retire and said, someone else's job. And they've gone as far as, there's our backup guys coming. The van.
Is there one currently always assigned to follow or trail from a distance every fully autonomous vehicle? Or are they just kind of hanging around? If you can say that.
Tesla's going to do their own insurance to try to say.
Actually, they're not
to use our
assigned
self-driving
per
cars,
vehicle.
which
They are going to be in the
other companies
area.
probably will be like, oh, we don't trust you.
There may
We're going
be
to get higher
2
rates.
vehicles. We don't know how
it's
many
interesting.
vehicles in the area.
That's going to be another industry they're going to disrupt as well.
Area
okay.
where some of those vehicles will be.
But the point here is,
usually between 2
the
and
guy
5 miles
comes to fix the car, and the car decides to start driving and escapes from the guy.
It's a little different than it used to be, I think. Okay.
So.
Cool. It never was assigned 1-to-1.
So I guess he's looking. Well, I doubt it. They're more. Yeah, 1-to-1's in.
Assigned 1-to-1.
But so basically, the car does figure out, and then it backs out. So it's backing up now.
We're backing out.
And now it's really blocking the road. Meantime, the guy's trying to get to the car. He's like, "Oh, I'm going to step back. I'm afraid." Right? The Waymo helper. And the best part is,
very interesting.
While they're waiting, and the Waymo assistance guy's like, "Well, should I get close to the car?" I think they have like a kill switch.
Now it's blocking the whole lane instead of.
Here comes the reason the problem started. The construction guys picking the cones up after painting the lines or whatever.
Actually, now it does look like it's confirmed. So with that, they should be dispatching. There comes our driver. His ETA is right now.
Oh.
Should be pulling it behind.
Okay, and the other interesting thing adding to this mix is that the construction people are about to take the cone away.
People get mad, they beep the car, but it's a self-driving car.
Yeah.
So they took the issue away. Now the car resets, and the car actually drives away until it's another set of cones. Stops again. The guy from Waymo was chasing after him, trying to.
Very interesting.
I mean, would you feel safe in a car like that?
You
Taxi?
should be there any time. I'm
What do you
looking
think?
at the camera in the back.
I guess once you've done it once or twice, you don't feel like you're locked in. I guess you can always hit a help button and they can open the door for you.
Metro somebody.
See, that was an accident right there. Car pulled out. The other car almost hit him.
Oh man!
Now the car's escaping from the Waymo helper guy. He's got to jump in his car and chase it now.
What do you know?
Everything's good, right?
Okay.
Except there's more cones coming up. Next intersection. The same thing happens again. Eventually they do wrangle it. And I guess they eventually do a kill switch for the car. I don't know. But yeah, it's through this next intersection. Here's the route on the side here showing where it's supposed to be going and where you're supposed to, blah, blah, blah. Past the intersection, there's more cones going up here, and the car gets confused. And the lady's funny. She says, should I stay on with you?
So it looks like you are moving right now.
Yay.
That is correct.
Except not really.
Woohoo! Do you want me to stay on the line with you? Make sure.
Stops.
Yeah, maybe a little bit. It really does not like these cones.
Not a problem.
Yeah.
See, it wants to swerve between the cones somehow.
Yeah, so on the planner route, I don't know if you can see the planner, but it wants to go halfway between lanes.
And this guy's YouTube channel, which just rides in Waymo cars, takes videos like this, and makes money doing this. He's got a following. I thought it was fantastic.
Yeah, now the hazards are on.
Yeah, the car kind of stopped. That's the other thing. I mean, will cars? A lot of these cars will stop in the lane when there's an issue, and Tesla's trying to get smart enough so they're going to actually pull over for lane changing now to see where it's safe, pull over to the side and put their hazards on, and you disengage.
What a sweet video this is going to be.
Watching the road and stuff like that. So.
Woohoo!
So the guy came to rescue him, I guess.
I like this.
So now they're going to be exit the vehicle and entering the autonomous specialist side door to complete your trip in manual.
Gotcha.
But the bottom line is it pulls out again, takes off again, he has to chase him over time. Anyway, that's the end of the video. But thank you for coming for the talk. I hope it was fun. I have lots more stuff, but we should look at stars.
Escape.
It's running away.
He got
second time. We get back and chase him again.
Car took off again?
Yes. Well, a little bit, and then it's. This is now it's. I don't even know what's going on anymore. Yeah.
They've seen hundreds of rides, so this is the weirdest one I've seen yet. But things like that. No, you're locked in until they somehow there's a get out button, but then the humans got to make sure and it's really stopped and open door button and stuff like that. But yeah, so is it ready for prime time? I don't know. I mean, I think level 5. I don't know, but level 3 maybe. Maybe your car you get your FSD downloaded and it starts driving better for you, and be careful and watch. And I've watched many videos of people who've driven across country that way, and it's just enjoyable. I guess right, it's just easier and less fatiguing and stuff. So there's certainly benefits. And my hope is someday my son, who's 11 and a half, will not drive. The car will drive for him. And it'll probably be safer. So. It's per country. So they have the English version, right? And Tesla's in England with autopilot, they work.
And you go to England or Australia, it says this shown is the US model. It's like, oh, I selected.
Now, I've seen videos of guys who are driving in Europe and they've had autopilot.
You should show me Aussie car, not for display purposes, you're looking at the US model.
Yeah, that's just Elon not paying for a marketing department or all sort of stuff. So, but
you can see on YouTube people driving.
Yeah. Or many of those channels where people are, reviewing stuff. The European guy I watch a lot. He's doing it, and but they're gonna have to train per country, But I'm sure they will with the models. They're just pushing out in the U.S. first with FSD, and hopefully in the next couple of weeks, once you'll actually get what you paid for. my thank you. I own a stock. Thank you. And
so with Tesla stuff, I thought that it said in there that they're using the input from current drivers. Is that correct? Like if you own a Tesla, and you're driving, even though it's not a self-driving car per se, they're using input to make this work better.
Right. It's called shadow mode.
Right.
They're pushing out a model, and it's actually the car's driving, but it's not connected. And it says I should turn here, or why don't you move? And then when you do something different, it says discrepancy. Sends it back, and then people will look at it. Humans say, "Well, he got in the lane. Maybe he should be in that lane for a turn." Classic things are in Chicago.
That in every Tesla now that's on the road.
Supposedly, the newer Teslas have version 3 of the self-driving hardware already installed, and Tesla's gonna have a subscription service. For $200 a month, you can turn it on and play. So, but the older cars may not have that. But the ones that can support it, they're pushing those models down to those cars because it's a test too. Because as they go from maybe 1 million cars this year, I'll give them 2.1 million on the road to more. Can they push out to those cars? But yeah, they're actually watching, and yeah, right. And no one else is doing that. The only other company would be Comma AI. George Hotz is playing the same game with his cell phone, but he doesn't have as much data because he has less owners. But he's getting some of it back. Yeah, and then like I said, Mobileye is the other big contender, and they're now getting feedback, but they're bringing back not just weird edge cases. They're bringing they probably are, but they're also bringing back models of the world to kind of update their high def models, which Tesla stayed away from and said we're going to build it on dynamically as we go. And that could be their Achilles heel too, because how far can they plan out? But they can watch a couple of seconds, up to 6 seconds, where road might turn stuff, and they predict stuff. And even the vision systems were actually predicting object permanence and things went behind fog and stuff and reappeared, kind of track where it should have been. So it's actually pretty impressive. And so this is, just on the AI side, this is the high profile version of AI and machine learning. There's more important stuff like that's happening in cancer research, ophthalmology. Amazing things are happening. The doctors, I look in your eye. Well, it's different from last time, but the computer says, I saw 1 million of these, and this is exactly what this is. That's a diagnosis. Sorry, doctor, you're wrong. I guess I'm wrong. So there's a lot of stuff happening. And so my next talk will be on that in October, about all the AI stuff, because there's a lot of spin-offs of this stuff. Well, that's just the AI stuff, but this is the self-driving, because last week or whatever was, what's his name, talked about his car. And I thought that was pretty cool. So hopefully, I'm not sure how to go on the outside, if anyone's even watching out there, to get questions. Well, Waymo, not quite. They're a hybrid of some. So I'm not sure which flavor, but it doesn't have to be. Matter of fact, it's probably better if it doesn't, because the guys who are using more computing power need more energy, so they use gas. But it doesn't have to be.
You said some of the systems don't build their cars; they add to it.
Right. Well, like the cell phone guy, just put it on your car. That's and but don't push the EVs. I think is another discussion. But that's just because governments are saying, green, blah blah. So that's happening. And Tesla sort of did that, and so everyone's making their couple of cars, and we had a whole discussion on batteries and sourcing and what's useful. And actually, you'll love this. Tesla had a battery fire at one of their power facilities in Australia. It happens. So, but the bottom line is they're going more toward lithium LFPs, lithium iron phosphate, which actually are non-flammable. It turns out there's a patent until 2022 in China for LFPs. China makes them all, and I got a couple from Ham-Radios work really well. They have high cycle rates, not as energy dense, but they started doing this for the cars for 250,000 or 250 mile ranges and up in that range, 250 to 300. They're LFP batteries. They have to put more in a car, makes it a little heavier. Maybe that's a solution temporarily until they can do other chemistries with the lithium-ion battery stuff, which are flammable. Yeah.
It just bothers me.
Yeah. Well, anything happens because of the big dollar, right? So this is happening because there's tons of money for automation. EVs, the battery companies are going crazy because all the manufacturing batteries now. So that's from the mining to the right down the line to everything. So this will happen not because it's a good thing to happen, because money's going to push it, and it'll eventually get there.
Yeah, because if it's between me and
in my opinion.
driving the car.
Yeah. But even so, a quick question to this gentleman who has a Tesla. If you had situations where the car took over for safety, like a deer jumps in the way and the car swerves, I've seen videos and stuff like that. If you turn autopilot on, I imagine it watches, but even if you don't have it on, there's still something in the background watching for safety, so collide into somebody and stuff like that. So there's new stuff being added to all these cars, the level 2 stuff, which is just really good. I would just say Tesla's better, but all cars are better than my dumb level 0 car, which I'm got to drive home tonight, not hit the deer when I hopefully go down the road or something like that, down the hill. So hopefully people are online. I don't know how to get to the questions, but hopefully you enjoyed it. Show up here, Kopernik, some other day, and I'm here on all Fridays. I'll talk to you about all sorts of stuff like this. Okay. See you guys. So, see you guys. So I'll go and get through.